Hello, Namaste. Welcome back to the course on Geographic Information System. So, we have discussed about database. We have looked at SQL. We in the previous version we looked at very basic spatial analysis and how the database, how the geometric data is stored, how the GIS data is stored, and how we can understand different operations using arithmetic, logical, statistical operators, and Boolean operators. So, once we have understood all of these things, now let us look at some spatial analysis based on tools. Okay. So, there are certain science behind these tools, the way it has been understood. So, we will look at some of this spatial analysis and how we use these tools in for various operations. So, when we are looking at this, we look at classification systems. Why do we need classification? For example, you have to you will put out the thematic maps once you have done your analysis. Why do you need such analysis? Then we look at overlay, we look at buffer. So how do we use buffer? How do we use a function called as overlay? And we'll look at all of these aspects as we go ahead. When we are looking at classification and reclassification, there is a first tool that we will be using. Probably in one of my modules, maybe module 5 or module 4, I spoke about the thematic maps. Yes, so when I say thematic maps, these are the ones which have a certain theme. Okay, if I am representing maybe the hydrological status of various districts in the state of West Bengal. Okay, so I may give some of the districts where probably the water availability rather than hydrological state, let me say it as water availability. Now water in certain districts are scarce. In certain district there is plenty of water. So if I have to segregate these things, then I would segregate it based on theme, that's a color. So if there is severe issues, then probably I would go with the representing it with red. If there are no issues, it is available in plenty, then I would probably represent in the form of green. So RBG format, so blue representing somewhere in between. So when we are looking at this kind, this is called a thematic representation. So similarly, you can use any number, any type of thematic representation, but when we look at this, the NRSC, there is NRC theme guide of how the representation has to be done in form of classification, and there is also the thematic representation style lines by Survey of India. So using those style lines, we can basically do this kind of analysis. So when we are looking at the same thematic maps, there comes your classification, reclassification. When you are looking at classification process, it involves attributes according to the limits set by the user. Let's say I have certain attributes which I have to be represented in different forms. Visually, it is the color that gives me more information as a user, okay, who may not understand what are the different things that are behind a particular value that has been arrived with. For example, if you are looking at, let's say, urban density or the alpha density value that we are looking at, if alpha density has to be reached, there are certain we take in population, then population density, then we look at area. So you basically a user may not need information about the area, the size, etc., but he or she may look at only the alpha density value. So alpha, higher the alpha density will show in red, and lower the alpha density will show it in the form of green. Okay, so now when you are looking at classification based on alpha density, so we will give a classification based on the values. We will give a range of values which is representing red, the range of values which is representing green, and this all of these scales are pre-built in any of the GIS software, where once you look at it, if you start looking at thematic mapping, it's much easier, and the colors are vibrant in terms of display. So reclassification involves changing attributes values without altering geometries. Okay, for example, classification involves the normal way of looking at both attributes and geometry, which by the user has been set as a limit. And when you are looking at reclassification, you are altering the attribute values but not geometry. Reclassification can be compared to changing colors on a map. Okay, so reclassification can be used to isolate object types also. Okay. In the raster GIS, built up area characteristics may be isolated by assigning 0 all other areas a value of 0, which is also called as thresholding. Okay. What you do is that if you want only the urban area to be given, let's say we have 4 land use types: urban, water, vegetation, others, right. So now what I'll do is that I'll give urban, I'll just do something like this. Okay. Urban, that is, let's say I have urban as first class, second is vegetation is a second class, third is water, and fourth is others. Fine. Now what I'll do is that I'll give 1 equal to 1, okay, 2 is equal to 0, 3 is equal to 0, 4 equal to 0, or 1 equal to 1 star equal to null. Is a simple statement. Okay. So now it is reclassified. Now I have only urban area, other areas are null, right. So this is where we use the same thresholding in terms of classification, in terms of raster analysis. Or another way of classification in raster data is using maybe automating in terms of supervised or unsupervised classification. So using a supervised classification, a user gives the input in terms of signatures, which actually trains that classifier in order to in terms of statistical significance, and also statistical mean, standard deviation, variance, covariance, etc. Using all these values, there is classification would happen. There are huge number of classification systems have been developed over a period of time for such classification. And similarly, you have other types which is called land cover, land use, etc. So this is about your raster data. I would not get into all those classification techniques. Okay. So just to give you an example, this is what it means by classification, reclassification. Now here I have given a classification for each of these. Let's say it is each district has been given a different color. This is a map of Karnataka. So each district I have given a color. Okay, for example, Bangalore district is here, which is given a particular color, and similarly Mysore, etc. are given different colors that have been represented here. Okay, so this is what is mean by classification. Now once we have understood classification, then how do you actually integrate a geometry and attributes for processing your data? So integrated processing is based on the condition that each object type is represented both in geometry and attributes. So always when you are looking at integrated processing, you should have both attribute as geometry, also you have to have attribute value also. If any one of these is missing, then your integrated processing may not happen in the way it used to happen. When I say attribute, for example, in this example I would take up in the entire course of time, as for example the ID is 1, 2, 3, and it is attribute is as development, recreation, and preservation, which means wherever one occurs, it is a land that is allocated to development. Wherever there is 2 that is being seen, that is where the recreation can happen. Where there is 3, then it is for preservation. So similarly, there is an ID for 1 which is cultivated land, there is 2 for grazing, there is 3 for forest. So these are the these are 2 classifications that I would take it forward. For example, when you say integrated processing, so if I use both of these layers, okay, so attribute value is cultivated, which is 1 here, and ID here is development. Attribute value, that is 2 here, is grazing, and again ID value is 1, that is development. So when both of this can happen when you are actually using both of the layers. Attribute value can be 3, and again ID can be 3, and there can be ID that is 2, which is again recreation. ID can be 2, which is grazing here, again that 2 is recreation. So these are different combinations of different IDs and different values that in the both the maps with the different geometry and different attribute values. Okay, so that I use. Now the first type of integrated processing is overlay. Now when you are looking at overlay is a kind of data integration and technical process that results in realistic forms of spatial analysis. That is, for example, you have one layer. I have shown this example much before also when we were discussing about thematic maps, etc. So you have one layer down, one layer on the top, another layer on top. So now you want to analyze effects of all of these three layers. Okay, so that is nothing but overlay. You are putting one on the other and trying to understand where for example here the development can happen. Okay, so there are normally three kinds of overlay. One is the polygon overlay, another one is a point on polygons. So when I say point on polygon, it is point that is overlaid on polygon for the analysis. When I say polygon overlay, it is polygon on polygon analysis. There is lines on polygon, which means lines is put on polygons for analysis. So all of this can happen when you are looking at overlay function. Polygon overlay is a special operation in which a first thematic layer contains polygons is superimposed into another to form a new thematic layer. Okay, so now when I say polygon overlay, so you have all as polygon, so you have another thematic polygon which can be used. When I am saying polygon here, it's not only one polygon which can be overlaid, any number of polygons until the data that you have. Overlay it, use functions to create some extremely important outputs. Okay, so when you are looking at point on polygons, here the points are superimposed on polygons. For example, for you to give an example here, there are four properties, that is there are four piece of properties, A, B, C, D, and we have four IDs which are representing four building numbers. So each of this, if there is a building number in the property A, so it has a certain property number, that is 44 by 110, that is represented by 1. So now if you want to look at what is if you have allotted it to someone and it has to be developed as a property. So if someone wants to analyze what kind of soil is there, what kind of how the foundation has to be laid, etc. So just using a soil layer on one of and other geographical layers that have been already shown here. So use these three layers to extract what is a kind of soil layer in that particular region. Then once you have extracted it, then probably you can find out how the foundation has to be laid. That is up to the other civil engineers who are actually looking at that part. Okay, so they can extract information rather than going testing the soil on the ground. So if most of these layers are now readily available online. If you go to Bhuvan, you can get soil layers, etc. So and many of this the state remote sensing centers will be able to give you most of the layers that I am actually explaining. So if you go get those layers, so probably you can use it for any kind of analysis. Then you have lines on polygons. Let us say that I have this is a road line, these are the different polygons. Now I have to find out this is the one road line that is now proposed. Now I have to find out this where does this road goes, which are those areas that are affected. If that areas is a particular protected forest, or it is an protected area, or it is an commercial area, or it is an any of the houses, etc. So if I have to find out, I'll just overlay these lines on those polygons. Once you have put these lines on those polygons, I can find out where this is going, what is the effect that it may have once the road is being built, what is the size of the road, and if there is extension, what may happen in the future. So such kind of analysis can be done when you overlay lines on this. So that is a different way of thinking that usage of overlay analysis. So as I said, overlay can be many types. Okay, you can use union, you can use intersection. So union combines and keeps all the features, that is polygon on polygon overlay only. So if this is an polygon and this is a polygon, it actually union has combines both of these. Normally polygon on polygon overlay only does this. Intersection, it combines and keeps only the common features. For example, if you look at this and this, the common feature is only this. So both of this the other areas are cropped and kept. A very good example is that when you want to actually create your study region based on the boundary, so you crop the other regions and put it out. So that is where the overlay helps, and it is a very good tool in your GIS software to actually look at various aspects. So this is one example that from Maribeth, Professor Maribeth, who showed how an intersect tool can help in various analysis. For example, this is one area. um if you intersect and union tool. So if this is the region that we are trying to analyze, if there was some error or calamity in this particular region, so when you look at intersect, what it basically does, it gives you only the region which is affected, which is this, okay, with two data sets. If you look at union, both of this will be accommodated here, okay. So now if you want to look at only the regions that are there here, then you will probably use intersect, which is affected by certain phenomena. But if you want to look at the entire region including that region that is affected, then you use union tool. That is what it is basically representing. Another example of union is this: you have a geology map, you have a slope map. So if you do union, which means to say you get both of these on together. Now with this you can look at where there is a high risk of landslides. So you use both slopes and geology map, so you will say where the landslides are high. Then intersect example, you have a residential area here, you have an Obeche formation that is happening, it may affect the residential area. So where it affects, so just intersect, you will know where it may affect in a larger scale. So this is the area that that's what the example that I showed previously, okay. So hazards mapping is another way of looking at this. You can apply this on hazards mapping. These are some example as adapted from Professor Price. So if you can see, these are some of those which you can see. And habitat analysis, this is an extensive usage now in terms of how do you look at habitat. Now here it is a snail habitat which we are looking at. You have elevations, these are the ones which are normally in a bit of lower elevations and more in terms of dense conifer forest, and where basically there is limestone. So what we'll do is that we'll look at elevation, we'll look at limestone, and we'll look at coniferous forest. Now with intersecting, we all three, we know that where the elevation range is medium, and we know that where the limestone is located and where the coniferous, all three are located. Once there is located, that is a probable area where the snails are located. So once you locate those areas, you can find out where the real locations of the soil. That's why intersect can be used extremely as a useful tool in analysis. Intersecting using different geometries, yes, you can do it. So there are two different geometries that you can see, whether it is an intersecting polygons. Choose polygons, lines, or points for outputs. How do you want to get your outputs? So output dimension must be less than or same as a lowest input dimension. So that you should keep in mind. So it will be the same. Then intersecting lines, choose lines or points. If you want the output to be in a form of points, or you want to have output in the form of lines, how do you want the output? So look at those ways of providing the output. Then intersecting different geometries. So this is very important for applications, especially in the urban data. Okay, for example, there is one geometry here where and there is another geometry. So these intersecting polygons, you should choose either it is lines or polygons. Why? Why I say this is that you should be extremely careful on what data you are trying to export. What is the report that is being given to the user? Whether you are giving a report on how denser the street is, or you are giving a report on where there are intersections in that particular street network. So intersecting points with anything else always yields points, okay. Intersecting points with anything else yields only points, okay. Intersecting lines can yield both line and points. Intersecting polygon can yield polygon and lines, okay. So having you should be able to understand, interpret it. It's a reverse logic of how the vector model is built. Then the next tool is dissolving. Very important tool if you are trying to represent any vector data. For example, let's say that these are different maybe I can say different forms or different fields that are there in this particular vector data, okay. So when this different fields, based on these fields, each of these geometries are shaped, and in case let us say that I want to dissolve all of these into single, for example anything that is C will be put into single thing, where anything that is B is put into single, anything that is A any other F is put into single. So it just using dissolve you can put this into single line, and if there are many intersections like this and you want to represent a main street, just using a dissolve can put it in the single line segment with only two segments at end and the end and the tail, which is for representing the entire main street. So this is how a dissolve tool can be used, and if someone is using ArcGIS, I am sure that he or she would have used this tool extensively. Okay, so dissolving eliminates all the attributes in the table except the dissolved one. Okay, please keep this in mind. This is where you lose the data. That is what I said. If you give an exclusive access to the user, he or she, if they use dissolve and save that data, all your data is gone. So look at where he or she saves. She can import it, use a different form to do it, and save that data instead of saving it the main data. That's how you have to create your entire database. Okay, so and you can choose summarize other attributes which are related if it is not dissolved. So whatever it is dissolved, you lose those attribute data, and only the things that are not dissolved would remain as it is. There is something called as append. For example, places with features and a feature class into existing feature class of the same type. Okay, so for example, if there is one vector data that is like this, okay, that is represented in blue, there is another input which is in this. If you want to append both of these, combine both of the attribute data, combine both of the geometric data, and then place it in the output like this, it does it by default using the append button. Append, unlike union, it does not attempt to split or change features. The features are simply brought in. It is like copy paste. Instead of union, it looks at using both if there is certain commonalities, so use that. But here it is unlike that, it is just a copy paste thing. Okay, copies from one layer to the other layer and pastes it. That's it. Whether it is correct, whether it is not, topology is correct or not, it doesn't look at it. If they overlap, you will have double features in your database. So look at this. That is one of the issues in terms of append. Then there is merge. So for example, you have let us say you have created two layers, and this happens normally in your satellite data. You have two different raster data, so both representing, if for example if I am taking Hyderabad data, Hyderabad may be in 2 or 3 or 4 images of with respect to a particular spatial resolution. So let us say for 2 images that I have. Now I have classified both of these images for different issues. So now I want to combine both to be represented at a single map. So what you do, you input both of map A, map B, and then use merge. So what it does, it looks at the common boundaries. If there is an overlap, okay, for example, this is something, this image is covering this area and this image is covering. So the top hand, the right hand is actually covering more area than the previous on the left hand. So what it does, it sits on it like this. So it matches its edges or its latitude and longitude or its points on these edges. So that is how the merge happens. So normally overlaps are always permitted, and overlaps are considered to be correct in terms of merging data, so that the data is not lost. So then you have, I spoke about the raster data overlay. So it is cell to cell comparison, which is more of cells based on the thematic layer. There are new cells are registered as a new thematic layer. Whenever you create new cells, normally it is a new thematic layer. Then the concept of buffer zones. Okay, buffer zones are used to define spatial geometry. So these comprises one or more polygons of a prescribed extent around the points, lines or areas. The new polygons have an attributes of original objects. when you create a buffer, the attribute is of the original objects. Or for example, if this is the area that I have taken, so you have a buffer zone that is linked around it, so they have the original objects that is linked to it. To summarize this particular class, we looked at both classification and reclassification. So we said the classification is both more is equivalent to thematic representation. We are trying to classify it based on certain attributes that are there in the data set. Then we looked at how do we process a geometry and attributes. We looked at overlay analysis. Overlay analysis is extremely useful in terms of using it, and we said in when you are looking at any of these geometry and attributes, we are looking at union and intersect functions. Union gives you union of both of the geometries that we take, but when you are looking at intersect, it is the common geometry, and we have polygon intersection, polygon line intersection, or a polygon point intersection, where the base is the polygon part. And when you are looking at buffer analysis, we are actually looking at the attributes which are common with the same area where we are looking at the buffer. Buffer is some, I mean, for example, if you are looking at urban analysis tool, if you have already done a land use classification for a certain region, okay, now let's say that you should understand what is actually the sprawl area that is out of this urban area. It is simply done as simple as this. So you consider buffer, so that region is now you can do the land use classification, validate it. Now you know where the spurt of the urban area has happened, okay, extract it, look at different networks, different regions of how it is interacting and why the growth has happened. And if the growth has happened logically, then you can say these are the reasons, or you can use different metrics to quantify that growth and say how the sprawl has happened over a period of time. So that is why the buffer analysis may be extremely useful, and buffer is normal, I mean, for various reasons the buffer analysis is used, and probably once you start exploring, you will understand why it is being used. Okay, so this is what is for this class. So I'll meet you in the next class. So we'll look at some of the operations in QGIS. We'll go back to QGIS. I would like to take it up in more detail about certain operations that we'll do it, and we'll perform various tasks in those operations when we come back. Until then, thank you very much.